So now there's one part left of this topic, which is also in integration, but we're using substitutions. So just like in normal trig, how we have trig substitutions, here we can have hyperbolic substitutions. So if you see here, we've got the integral of 1 over the square root of x squared minus a squared dx. Now in our formula book, we have the integral of 1 over the square root of x squared minus a squared, that's r cosh of x over a. And that is exactly what we have here. So basically we're just going to prove that it's equal to r cosh of x over a. Well, we can use this by using a substitution. So in normal trig, we'd use a tan substitution because we've got x squared minus a squared. So that would be a tan substitution. So we could solve this using a tan substitution, but we could also solve this using a hyperbolic substitution. So that's what we're looking at today. So just like a normal trig, we have to use identities. So our main identity, because we've got something squared minus something squared, we know cosh squared x minus sine squared x is 1. But if you see here, these are like x terms, but here we've only got one x term and we're minusing like a constant. So the constant here would be like 1. So we have to get it in this form of x squared minus a squared. Well, to do that, what we're going to do is add sine squared x to both sides and subtract 1. So as if it's like an equation, so we're going to get cosh squared x minus 1 is sine squared x. Well, now we've got it in this form of the x term squared minus a squared, which is this. So we get sine squared x. So we can see that this square root here will be something to do with the square root of something sine squared x, which is just going to be sine x. So we see the cancellation working from these substitutions and identities. But because we've got a squared over here, if we just added a squared to both sides, we're going to get a squared cosh squared theta minus a squared is a squared sine squared theta. Well, that's what we've got here. We've got this x term squared minus a squared, x term squared minus a squared. So we're going to get the x squared term is going to be something to do with a squared cosh squared theta, or x. Well, that just means x a cosh theta. I keep saying theta a cosh x. So we're going to make the substitution of x is equal to a cosh x. So x is a cosh theta. Oh, that's why I kept saying theta, because we're going to make that substitution. Or we could use u, a cosh u. I'm just going to use theta. Well, now if we now this just becomes like a normal trig substitution thing. Dx is equal to a sine theta d theta, and the square root of x squared minus a squared, so the square root of x squared minus a squared, well, that's going to be the square root of a squared cosh squared theta minus a squared, which we worked out would be a sine theta. Well, let's just show that. So we'll get the square root of, factor out a squared, so we're going to get a squared into cosh squared theta minus 1. And then we know our substitution, we know our identity is cosh squared theta minus 1 is sine squared theta. So we can substitute sine squared theta there, so that becomes the square root of a squared sine squared theta. Well, that's just a sine theta. So now we can transform our integral. So what we get is the integral of 1 over a sine theta multiplied by dx, which is a sine theta d theta, that. So what we get is the integral of basically 1 d theta, which is theta plus c. Well, we said that x is a cosh theta, so theta is going to be arc cosh of x over a, because we divide by a on both sides to get x over a, and then we take arc cosh on both sides. So it's arc cosh over a plus c, which is this if we want to use our ln form. So we've proved that for this integral over here, it's arc cosh of x over a plus c. Okay, now let's try this one. So we've got 1 over the square root of a squared plus x squared. Well, now if we write our identity, we've got cosh squared x minus sine squared x is 1. Well, here we've got the constant term added to the x term. Well, the constant term is 1, and then if we see, we've got minus sine squared, so we can add that to both sides. So we get cosh squared x is 1 plus sine squared x. And then because here we've got a squared and x squared, well, to get everything in terms of a squared, we're going to multiply everything by a squared. So we get a squared cos squared theta is a squared plus a squared sine squared theta. So here we've got our a squared and x squared term, a squared and x squared term. So this square root will transform to the square root of this, which will be the square root of this, which is a cos theta. So the x squared term is a squared sine squared x. So what we're going to do is make the substitution x equals a sine u this time. So dx is going to be a cos u du, and the square root of a squared plus x squared is going to be the square root of a squared plus a squared sine squared u. Well, we can factor out the a squared, so we'll get a squared multiplied by 1 plus sine squared, which is going to be cos squared. So what we get is the square root of a squared cos squared u, well, that's just a cos u. So our integral over here becomes 1 over a cos u multiplied by dx, which is, well, a cos u du. So that and that cancel, so we're left is the integral again of 1 du, which is just u plus c. Well, we said that x is a sine u, so x over a will be sine u, so u is r sine of x over a. So that's r sine of x over a plus c. So our integral is r sine of x over a plus c, which is this one over here. The integral of 1 over root a squared plus x squared, what we had over here. So we can prove these results. So now, let's try this integral over here. So we have to show that this integral of 1 plus x squared all square rooted dx is a half r sine x plus a half x root 1 plus x squared. So this looks like there's a lot going on. Well, we've got this 1 plus x squared. Well, from this integral, a squared plus x squared, if we let a is 1, we're going to get 1 plus x squared, which is just going to be a substitution of 1 sine u, which is going to be sine u. So what we're going to do here is let x equals sine u. Well, dx will be cos u du. The square root of 1 plus x squared will be the square root of 1 plus sine squared u. Well, that's just going to be cos squared u, so we've got the square root of cos squared u, which is just cos u. So this integral becomes the integral of 1 plus x squared, which is cos u, multiplied by dx, which is cos u du. So we get the integral of cos squared u du. Well, now here we can use some Osborne's rule, we can use a identity. So I mean, we could say that cosh squared u is 1 plus sine squared u, but then we've still got squares, and it's hard, just like a normal trig, we can't directly integrate like a trig thing like squared, except if we have like sec squared, but we've not got sec squared or sec squared here. So let's work in terms of trig first, so we'll do it on the side. So cos squared x. When we're trying to integrate cos squared x, we use the identity of cos 2x is equal to cos squared x minus sine squared x, and this sine squared x is 1 minus cos squared x. So what we get is minus 1 plus cos squared x, so we get 2 cos squared x minus 1. Well, we want to make cos squared x the subject, so we're going to add 1 to both sides and divide by 2, so what we get is a half plus a half cos 2x, and that's cos squared x. Well, now if we use Osborne's rule, well, there's no signs anywhere, so it's just going to be a half plus a half cosh 2x is going to be cosh squared x. So our integral is the integral of a half plus a half cosh 2x. Well, we can factor out the half and put it outside, so we get a half 1 plus cosh 2u du. Well, now this is easy to integrate. We're going to get a half lots of the integral of 1 du, which is just going to be u, plus the integral of cosh 2u. We know that the integral of cosh u is sine u, so then if we were to work backwards, if we had to differentiate sine of 2u, well, that would give 2 cosh 2u. So to get rid of the 2 in front, we multiply by a half, so it's going to be a half sine 2u plus c. Well, then what this becomes is a half u plus a quarter sine 2u plus c. Well, x is sine u, so u is r sine x. So what we're going to get is a half u, which is r sine x, plus a quarter sine of 2u, which is sine of 2 r sine x plus c. Well, that's not going to get us anywhere because we've got sine of 2 r sine x, which we can't like simplify properly. So it's not going to be this. We have to think about something else to do. Well, we see we've got sine 2u over here. Well, if we had sine of 2u, that's 2 sine u cos u. So therefore sine of 2u is 2 sine u cos u, using our double angle formula. So we get is a quarter of 2 sine u cos u, which is going to be 2 over 4, which is a half. So a half sine u cos u plus c. Well, we've almost got this. We've got a half r sine x, then we have to get a half x root 1 plus x squared. Well, we're almost there. We've got the half r sine x over here. We've got the half, but then we have to get x root 1 plus x squared, but we've got sine u cos u. Well, earlier we defined sine u was x and cos u was the square root of 1 plus x squared. So we can just use that substitution here, where we're going to get a half r sine x plus a half sine u, which was x, cos u, which is square root of x squared plus 1, or 1 plus x squared, plus c. And that's our answer. We've shown that this is equal to this. So now, one last question. Use the substitution x is a half 3 plus 4 cos u to find this integral. Well, we're told what to do. We have to substitute x for a half of 3 plus 4 cos u. So let's just do that. So our integral, so we're going to put x is equal to a half 3 plus 4 cos u. Well, dx will be a half. The derivative of 3 is just 0. The derivative of 4 cos u, which is 4 sine u. well, 4 over 2 is just going to be 2, so 2 shine u du. Okay, now let's transform this square root. So 4x squared minus 12x minus 7. So 4x squared minus 12x minus 7. Well, when we make our substitution, we're going to get 4 lots of x squared, which is half 3 plus 4 cos u squared, minus 12x, which is this. So we're going to get 12 multiplied by half of that, which is going to be 6. So minus 6, 3 plus 4 cos u, and then we're minusing 7. Well, this will become a half squared, which is a quarter, so we're going to get 4 times a quarter, which is going to be 4 over 4, so we're going to get that. So what we get is just 3 plus 4 cos u squared, minus 6 times 3, 18, minus 24 cos u, minus 7. Well, here when we expand this out, we're going to get 9 plus 24 cos u, plus 16 cos squared u, minus 18 minus 24 cos u. So we know this and this will cancel, and we're going to get minus 7. Well, minus 18 minus 7 is minus 25, then we're adding 9, so we're going to get minus 16. So what we get is minus 16 plus 16 cos squared u, which is 16 cos squared u, minus 16. Well, factor out the 16. Well, we know cos squared u minus 1 is sine squared u, so we're going to get 16 sine squared u. Well, that looks a lot nicer now, so therefore our integral will be transformed to 1 over the square root of 16 sine squared u multiplied by dx, which is 2 sine u du, well, that becomes the integral of 1 over 4 sine u times 2 sine u du. Sine u cancel, and 2 over 4 cancels to a half, so what we're going to get is the integral of a half, so we'll bring the half out, du. Well, that's just a half u plus c. What was u? Okay, so we have to find u, so what we're going to get is multiply both sides by 2, we're going to get 2x is equal to 3 plus 4 cos u. So 2x minus 3 is 4 cos u, so 2x minus 3 over 4, so 2x minus 3 over 4 equals cos u. U is equal to r cos of 2x minus 3 over 4. So what we're going to get is a half lots of u, which is r cos of 2x minus 3 over 4 plus c. There we go. So we see, just like a normal trig substitution, we can use hyperbolic substitutions, and we can get help from these over here. So I hope this was helpful. This is now the end of hyperbolic, so I've got nothing left to go over. So I hope this was helpful. I can maybe do some exam questions if that would be helpful, but for now that's all. Goodbye.